I'm George, founder and CEO of Pathr. Pathr is a real-time spatial intelligence platform. What spatial intelligence means is we gather and produce location data, tracking information about people moving through physical spaces, and we connect that tracking and that location to business cases that the operators of those spaces care about. We work a lot in retail. One example of a use case that we address is customer and staff interaction in brick and mortar retail stores. We also look at various operational analytics, checkout throughput, length of queue, some loss prevention, different types of fraud and shoplifting, and so on. But like many companies, a couple months ago, we started shifting our focus to what we could do in this new normal and what kind of analytics we could produce given the current challenges that operators of physical spaces are facing. One of those things was social distance. Social distance analytics, understanding the spacing between people as they move through physical spaces, is something that's right in our wheelhouse. So we've been able to adapt our platform pretty quickly and pretty readily to be able to address social distance analytics and to understand how people are spaced and how they interact with each other as they're moving through these physical spaces in a way that's dynamic and not just based on static space allocation like a fire code would be. So what we're about to see here is a simulation. So we've taken our simulation platform that was originally built for internal use. We use this to bootstrap our analytics and to build demos and so on. We've adapted that simulation platform to produce realistic data about how people move through physical spaces. And when I say realistic, it's statistically validated information based on AI that resembles real shopping behavior in these physical spaces. We take that simulated data and we perform analytics on it. What we're about to look at is a visualization of that simulation and the statistical information that we gather from that. So this is a big box clothing retailer where we're allowing artificial intelligence shoppers to move through the space. And then you can see the red dots are unsafe contacts. Unsafe contacts here are defined as coming within 6 feet of another person for any period of time. But that's an adjustment, that's a configuration that we're able to do. So we can vary that distance, we can vary the amount of time. You see that we collect those unsafe contacts over time. Here we're looking at just a couple minutes of data. We run this for hundreds of hours in the cloud so that we can get statistical power, so that we can really understand how these unsafe contacts will play out in that physical space over the course of time, given real shopping behavior. We can also do these same analytics not in our simulation environment. We can use real data that's gathered from in-store surveillance or other sources of location data, and the statistics work exactly the same way. So what that lets us do is produce a social distance score. And we can use that social distance score in order to give more information about how that physical space is performing relative to social distance. So here, for this level of traffic, the social distance score implied that this space is risky. When we look at the fire code, of course, that's very risky. We're able to make a recommendation as to the correct number of occupants, and we're also able to make suggestions about how to improve the space and how to improve flow through the space. We pull out the bottlenecks that our simulation and that our analytics have produced and shown, and then we can identify ways to address those bottlenecks. Here's how to improve flow in these areas. And if you do improve flow in those areas, here's the number of occupants that you can successfully support and provide a safe environment for customers and staff. We're showing a distribution of unsafe contacts. This gives a sense of whether those unsafe contacts are localized to one area, which would imply one type of a solution in order to address that, or whether they're spread throughout the space, which would imply a different set of solutions. So these are just 2 pages from the reports that we produce using these analytics. There are several more pages to those reports, but these are 2 of the highlights. At the top, you see a block diagram of how our system is actually put together. What we just saw on the left is a simulation data source. Those are our 2 different data sources. We use either existing sources of location data, like existing surveillance, or we can use our simulation environment. Either of those can produce location data that feeds into our behavior engine. This is sort of where the special sauce lies, and where we do our analytics, and then those results flow out through our outbound API on the other side, in this case, through our cloud analytics API. We have different ways that we're offering this social distance capability in our reporting. Bronze is you give us just a floor plan and you get back a basic score report. So it gives you a very high level sense of how a space is performing just given the layout of that space. Then in silver, we integrate other sources of information so that we can get an accurate view of foot traffic to the space. We can understand things like transaction times and other shopping behaviors and so on, so that our AI agents can more closely resemble the shoppers that are actually moving through that space. And we can give a more comprehensive score report because we've got that additional data. And then in silver, we'll also do a fleet report. So if you have multiple locations, we can compare one location to another and understand how they're performing relative to each other. And then when we go up to gold, this is where we can make recommendations. We can identify the bottlenecks, give suggestions about how to solve those bottlenecks, and give new occupancy metrics about a environment where those bottlenecks have actually already been removed. And then when we go all the way up to platinum, that's actual real-time monitoring. That's where we collect data from existing sources, and we can do exactly the same kinds of analytics as well as contact tracing. You'll notice that our environment is entirely anonymous. So those are just moving dots on a floor plan. In a simulation, of course, everything's anonymous, but even when we're collecting real data, the platform is entirely anonymous. So when we're doing things like contact tracing and unsafe contacts, this is all in an anonymous way. I'm going to end there, and I'd be happy to take some questions about what we're doing here with social distance. We have a couple different websites, of course, Pathr.ai, but then also socialdistance.ai has some more information about what we're doing in terms of social distance analytics.
Great, thanks, George. We do have a couple questions in the queue here. So first question is, what is the data source for these heat maps, video analytics?
So the data source for all of our analytics can either be our simulation environment, so that we don't need to actually touch the physical space. We don't need any data that's coming from the physical space to use that simulation environment. The source of data from a customer perspective is just a floor plan. When we do live analytics and when we actually analyze real data about a physical space, we can take data from any existing source. So typically surveillance video is a great source for that data.
Maybe there's another question in the queue here, and I'm going to bump it up based on that answer. Can this be accomplished if you don't have camera coverage throughout the store? It sounds like the answer is yes, but
yeah, the simulation work can absolutely be accomplished without camera coverage. All we need is some way to estimate foot traffic, and so we can get that for either from sales data if there is a traffic counter at the door, or we can even take a guess. We've worked with some customers where we'll actually just count people walking into one of the locations that we can see, and then we can use that to estimate foot traffic. So no camera coverage needed for the simulation.
Got it. And then another question is, can you change the occupancy limit to warn users when a store has reached maximum occupancy? Can this be done between multiple entrances in real time?
Yes, absolutely. Short answer.
Sure. So with our remaining Q&A time, I guess my big question for you is...
We got one more on the chat box.
Go for it.
And they want to know, are you doing this for corporate offices as well?
We are actually doing this for corporate offices as well. We're working a little bit outside of retail in corporate offices. We're working with a manufacturer at one of their plants. We're working with some retail adjacent spaces, shopping centers, bank branches, and so on. But yes, absolutely, corporate offices. One of our early customers is an engineering firm that designs corporate HQs, and so we're working with them on some of those.
Great. So with our last minute, I think went through all the questions. One more question for you. If someone wants to implement your solution today, what do they need to do to be ready to do it? And how fast can they go?
Email me with a floor plan and we're up and running very, very quickly. Should be able to have results for them the next day, if not shortly thereafter. And then those results get better over time as we engage more deeply.
Sure. Oh, and looks like we just got one more in. It says, I'm wondering if you could potentially use data from the PwC contact center tracing app. Corporate office would be interesting use case.
I'm not familiar with that particular app, but I believe so. We can use apps similar to that as a source of data for this. It would be another sort of a signal for our simulation environment to make it better and more accurate. So yes, I believe so, but I'm not positive of that.
Got it. Great. Well, thanks, George.